Long before humans launched satellites into orbit, even before the first compass was carved from a piece of lodestone, Earth already possessed a navigation system operating continuously in the darkness of the ocean. Imagine a moonless prehistoric nightlight cannot reach the seafloor. Sound is crushed by pressure, and scent fades away within a few meters of water. In that space, the first creatures capable of hunting by sensing magnetism emerged. Today we call them sharks, yet their ancestors were detecting Earth's magnetic field nearly 400 million years ago, before Jaws evolved and before forests covered the continents. Humanity, in contrast, needed centuries of mistakes, shipwrecks, and experiments just to grasp what nature had perfected since the dawn of life. The modern world often views GPS as a monumental achievement of human intelligence, but few realize that the force enabling satellites to function Earth's magnetic field is the same natural language that guided the oceans long before science existed. To understand the evolution of underwater navigation, we must return to where it all began, inside a strange biological organ smaller than a needle's tip, yet sensitive enough to hear the breath of a planet. On a shark's snout are hundreds of tiny pores, like scattered ink dots, connected to channels filled with mucus that lead into sensory sacs known as the ampullae of Lorenzini. In their simplest form, they resemble biological antennas, but instead of receiving radio waves, they detect subtle variations in electric and magnetic fields with astonishing sensitivity. Inside each ampulla lies a gel rich in ions, acting as a natural conductor. As the shark moves through Earth's magnetic field, minute voltage differences form along the walls of the sacs, similar to how a coil generates electricity when rotated within a magnetic field. The shark's body does not rely on a centralized processor like the human brain. Instead, electroreceptive cells function as a distributed sensing network, processing information in an analog manner without pulses, without commands. Because of this system, sharks do more than detect prey. They navigate with remarkable precision, sensing the north-south orientation without sight and traveling thousands of kilometers along migration routes that have remained stable for millions of years. The ampullae of Lorenzini prove a deeper truth long before physics became a formal science. Biology was already using electromagnetic laws to survive. While humans debated whether Earth was spherical, sharks were writing invisible maps guided by magnetism. But this natural map was not always gentle at times. It became the source of shipwreck stories that reshaped maritime history. Ancient navigation records describe certain seas as the Devil's Mouth, where compasses spun wildly, ships lost direction, and routes suddenly deviated from their charts. Sailors could not explain why the guiding needle seemed to betray them, leading to legends of sea monsters manipulating human instruments. Today we understand that the cause lies in deposits of magnetite beneath the seafloor. Massive mineral formations, born from ancient lava flows, create irregular magnetic regions known as magnetic anomalies. When ships pass through them, compass needles are pulled away from true north, no longer aligned with Earth's global field. In an era without GPS, an error of only a few degrees could be catastrophic. A vessel drifting 10 kilometers off course might collide with hidden reefs or become trapped in lethal ocean currents. These invisible deviations quietly shaped trade, warfare, and maritime politics for centuries. Ironically, the phenomenon that once terrified sailors became the very clue that helped scientists understand Earth's magnetic structure. Maritime history fractured. Yet through those fractures, humanity learned to read the ocean through the eyes of physics. Then, as the technological age arrived, a new paradox emerged. The 20th century produced radio, sonar, and computers technologies promising to help humans conquer the seas. But seawater again proved to be the ancient enemy of electromagnetic signals. Radio waves are absorbed almost instantly due to strong interactions with salt ions. Even extremely low frequencies used by submarines travel slowly and with limited stability. As a result, Even modern nuclear submarines, machines equipped with reactors, laser-guided weapons, and powerful computers face a primitive limitation. GPS cannot function underwater. Satellite signals cannot penetrate tens of meters of water, let alone hundreds. To navigate, submarines return to sensors that echo biological solutions, magnetometers. These devices measure subtle variations in Earth's magnetic field and compare them with maps of magnetic anomalies, a kind of dark map that represents the ocean through the lens of physics. A billion-dollar submarine moving beneath immense pressure ultimately depends on the same principle. Sharks used in prehistoric oceans, the stability of Earth's magnetic field. And that stability opened the door to the next step, turning magnetism into a technical standard for uncovering hidden secrets. When scientists realized that magnetic anomalies reflect geological structures, they began measuring them on a global scale. Aircraft and research vessels towed highly sensitive magnetometers across the seas, scanning vast regions to produce magnetic maps, giant X-rays of the planet's crust. These maps serve far more than geology. They help identify submerged continental edges, trace tectonic faults, and even locate ships lost for centuries. When a large metal object rests on the seabed, it creates a subtle disturbance in the magnetic field. That disturbance can be detected from afar, allowing marine archaeologists to sense that something lies hidden in the darkness. Through this technique, magnetism, once invisible and abstract, became a system of information. Humanity no longer merely feels the ocean like a shark. We decode it through vast data models. Each curve on a magnetic map tells a story: the drifting of continents, the cooling of Earth's crust, or a shipwreck swallowed by time. Magnetism began as a raw signal of nature, yet through human hands, it has become a technical language, a standard for exploration, discovery, and connection to the hidden history of our planet.